energy that can be transferred from one object to another, or even created due to the laws of other forms of energy. Imagine you have a pot of water on top of a gas cooker. Yeah, you have a pot of water on top of a gas cooker. The pot gradually becomes hot, and as the time goes by, the water starts boiling. It is seen that the gas cooker produces fire, and energy stored in this fire is transferred to the pot. This is why the pot becomes hot. This process is what we call heat transfer. Now, when we talk about heat transfer, we say that heat energy can be transferred or transmitted, usually from a hotter region to a colder region of an object. Do you know that there are three modes of heat transfer? One, we have heat by conduction. Two, we have heat by convection. And three, we have heat by radiation. We're going to start off with the definition of conduction. We say conduction can be defined as the process by which heat travels through a material with the particles of the solid remaining in position. Okay, I believe you start thinking of various materials that we allow heat energy to pass through them. Okay, these materials are what we call conductors. And take note that some materials are good conductors of heat. Examples of these materials are: one, we have cast iron. Of course, cast iron is a very good material that conducts heat. We have steel, we have zinc. These are materials that are good conductors of heat. We also have aluminium, we have tin, okay, we also have copper, we have silver. All these and most metals are regarded as conductors, good conductors of heat. Why some materials also are said to be good conductors, others are poor conductors of heat, or you call them insulators. And examples of these poor conductors of heat are: we have one, wood, we have cotton wool, we have plastic, and we have cloth. We're going to look at various applications of these good and bad conductors of heat. Okay, in time past, you see various cooking utensils are just made of metals, but these days we now coat them with plastic so as to avoid heat transfer to the handle. Also rugs, we have clothes that keeps us warm. We're now going to see a video to explain this fact. Explains why we say metals are good conductors of heat. Take a metal rod, clamp this rod on a stand. Fix a pin to the free end of the rod using wax. Okay. Heat the metal rod with a spirit lamp, a candle, or a Bunsen burner. What do you observe after some time? Note your observations. Does the metal rod melt? You will observe that the wax melts and the pin falls down. So we can conclude that the activity shows that metals are good conductors of heat, as well as the fact that they have. Wow, I guess that video was quite interesting and educating. Now you understand why we say most metals are said to be good conductors of heat. We are going to now talk about the next interesting part of this lesson, and that is heat by convection. What do we understand by conversion? We say conversion can be defined as the process by which heat is transferred in a liquid or gas by the actual movement of the heated fluid. I come again, I say conversion can be defined as a process by which heat is transferred in a liquid or gas by the actual movement of the heated fluid. Let's look at the various applications of the conversion current in devices. One of them is that the idea of conversion is now applied in terms of ventilation, the cooling of motor engines, domestic hot water system. This is because the conversion current work as a result of the movement of the heated fluid. Now we're going to see a video to back up this claim. Heat and learn how the conversion of heat takes place in water and air. Take a round flask and fix it to a stand. Fill the flask with cold water, then carefully drop a few crystals of potassium permanganate to the bottom of the flask. Now heat the water by placing a Bunsen burner with a small flame under the flask and observe the crystal. When the water at the bottom of the flask is heated, it expands. The expanded water is less dense than the surrounding water and therefore starts to rise. The cooler region of the water in the upper part of the flask, being denser, sinks. Observe the colored water rising up the beaker. Go across the top and then sink down to the other side of the beaker. This is what we call convection of heat in liquid. Convection of heat in liquid. Now let's get to know about the conversion of heat in air. Take a closed rectangular box with glass fitted to the outside of the box. Pierce two holes at the top of the rectangular box. Pierce two holes at the top of the rectangular box. Place two glass tubes at the top to form chimneys A and B. Next, place the candle below chimney B. Light it and hold a small ring piece of paper over chimney A and observe the movement of the smoke. You will see that the smoke entering the box through chimney A gets heated up by the candle and then comes out of the chimney B. This is because the air above the candle is heated and thus expands because it is now less dense than the surrounding air. It therefore rises out of the chimney. In doing so, the cooler surrounding air, being denser, sinks through the other chimney. The movement of the hot and the cool air set up a convection current, and the smoke produced by a piece of smoldering paper held above the cooler chimney makes the convection current visible. This is why we say that convection is defined as heat transferred by the movement of the heated fluid. Okay, and this such liquid or fluid, when heated, tends to move away from the source of the heat, carrying the energy with it, and it happens as a result of density. Heat by radiation. We say radiation is a process by which heat is transferred from a hotter to a colder body or cooler body without heating the intervening medium. This means it does not have to get
direct contact with the body to which it is applied. Examples of materials that exhibit this mode of heat transfer include, we have one, the thermopile, and others. We're going to see a video now to give you a practical example of radiation.
The flame, you feel hot. The air you feel does not certainly come by conduction or convection. Here you receive the heat by the third mode of heat transfer from one body to another in exactly the same manner as light. This is called radiation. In radiation, heat is transmitted from one body to another without heating the intervening medium, and it is also in all directions and at a great speed. Heat is transmitted from the sun to the earth by radiation. Then we say that the sun radiates heat, and this heat is called radiant energy. That is, the heat that comes from the sun is as a result of its radiation. Take note that all objects, whether solid, liquid, and gas, radiates heat. And the amount of heat radiated by a hot body.
I guess we are now grounded with the knowledge about radiation. Another instrument that can be used to demonstrate the variations in thermal radiation is a Leslie cube. These and many more we have learned today. I guess our class today was quite interesting, intriguing, and educating. I hope to meet with you again in my next class. See you. Bye for now.